Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 2, Part 4, and we are in Section 1, Matter and Elements. And we are going to be working using Avogadro's number and molar mass, and then we can convert among all the things, number of atoms, mass, and moles. So you'll be able to do all the things. So using Avogadro's number, and as you remember, Avogadro's number is 6.022 times 10 to the 23rd, and this will tell us how many atoms are in a substance. So how do we do this? If we are interested in converting moles to number of atoms, you first, as you know, write down what you know, write down the formula. Moles over 1 times 6.022 times 10 to the 23rd atoms over 1 mole equals your answer, which is going to be in number of atoms. Then you substitute in your numbers, calculate, and check. So let's do this. How many helium atoms are in a tank with 7.5 moles of helium? The first thing we're going to do is we're going to write down what we know. Okay, so we know that we have 7.5 moles of helium. So we have 7.5 moles of helium, and we know we're trying to figure out how many helium atoms, the number of atoms. So the next thing we do is we write down the formula. Moles over 1 times 6.022 times 10 to the 23rd over 1 mole equals our answer in number of atoms. And so that's up to you if you want to rewrite that down, but you do need to write out the calculation as we're doing this. So moles, we're going to have 7.5 moles of helium over 1, and then times 6.022 times 10 to the 23rd atoms over 1 mole. So 6.022 times 10 to the 23rd atoms over 1 mole, and then that's going to give me my answer. So first thing I'm going to do is I'm going to cross off my units that I can. I see moles is on the top, moles is on the bottom. They get to cancel, and I'm left with atoms. And I'm just going to do a double check. Oh, yep, that's the answer that I want. That's the unit that I want in my answer. So then I am going to pick up my calculator. I'm going to do the calculate step. And I'm going to take 7.5 times 6.022 times 10 to the 23rd atoms and divide it by 1. And do make sure you're comfortable with exponents and putting those into a calculator. And make sure you have a scientific calculator, because a lot of calculators can't handle that big of a number if it's a non-scientific calculator. Okay, so if you got 4.5 times 10 to the 24th, and then my unit is going to be atoms, you are correct. So let's talk about calculator readouts a little bit. Probably can't read that, but if you notice, mine said 4.5165E24, and the E means 10 to the power of. So it's times 10 to the 24th atoms. And again, just a quick reminder on sig figs, I have 2 here, so I get 2 there. All right, so we calculated. Now we're going to check, is that a reasonable answer, and did we answer the question? So, how many helium atoms? Yes, we did find how many helium atoms, and we know the number of atoms is going to be a really big number, and indeed, we have a really big number. So let's see, in 7.5 moles, so if I have 1 mole of helium, that's going to be 6.022 times 10 to the 23rd atoms. And then if I had 10 moles, that would be adding a factor of 10 on to my, and so then a factor of 10, instead of saying like 60.22 times 10 to the 23rd, it would be like 6.022 times 10 to the 24th, right? Like those exponents are factors of 10. So my answer should be between 1 mole and 10 times as much, because 7.5 is between 1 and 10. And so is my answer between 6.022 times 10 to the 23rd and 6.022 times 10 to the 24th? And I look, and it is. So that means we answered our question and we got a reasonable answer. Good job. So now I would like you to try doing that type of problem. And so you want to set it up just like we set it up and get an answer. We will be going over this in class. So let's see how we do the opposite, converting the number of atoms to moles. So the first thing you're going to do is you're going to write down what you know. You're going to write down the formula, which is original quantity in number of atoms times 1 mole over 6.022 times 10 to the 23rd atoms is going to give you my answer in moles. Then, like always, substitute in your numbers, calculate, and check. So let's try this. How many moles of silver are in 3.01 times 10 to the 23rd atoms? First thing we're going to do is we're going to write down what we know. So we know we have 3.01 times 10 to the 23rd silver atoms. And we also know we're trying to figure out how many moles of silver. So the thing we're looking for is moles of silver. So we're supposed to write down our formula. And again, I'll leave that up to you if you want to write that down. Original quantity over 1 times 1 mole over 6.022 times 10 to the 23rd atoms equals our answer. But you do need to set up the problem with me. So my original quantity is this number, 3.01 times 10 to the 23rd. 3.01 times 10 to the 23rd atoms. My original quantity over 1 times 1 mole over 6.022 times 10 to the 23rd atoms, and that's going to give me my answer. First thing I'm going to do is I'm going to cancel out my units. Atoms cancels with atoms, and I'm left with moles, which is indeed what I'm looking for. So now it's going to get a little bit trickier putting this into your calculator. So this is 3.01 times 10 to the 23rd times 1 divided by 1 times 6.022 times 10 to the 23rd. Basically 3.01 times 10 to the 23rd divided by 6.022 times 10 to the 23rd. So you'll want to make sure you put this number in parentheses and divide it by this number in parentheses when you are putting it into your calculator. If you don't, you're going to be dividing the first number by 6.022, and then you're going to be taking that answer and timesing it by 10 to the 23rd, and you're going to get a really wrong answer. So put the whole number in parentheses, divide, and then parentheses, and my 6.022 times 10 to the 23rd. So please take a minute, put that in your calculator, and get an answer. Okay, if you got something like 0.4998, you are correct. So I get 3 sig figs, 1, 2, 3, and so that would be 0.499, and then that next 8 rounds up, and everything goes up to 0.500. This one being placeholder, and then the other 3 being significant figures. And then my unit is going to be moles. So 0.500 moles. So we calculated, now it's time to check. So looking up here, how many moles of silver? Did we answer the question? Yes, our answer is in moles. Now let's see if we have a reasonable answer. So 3.01 times 10 to the 23rd is about half of 6.022 times 10 to the 23rd. The exponents are the same, so then first I have to compare exponents when I'm looking at really big numbers, and those are the same, and then I can look at the number in the front, so 3.01 and 6.022. So do we have about a mole? We have exactly half a mole. So we got an answer, and it's reasonable. Good job. I would like you to try this problem on your own. How many moles of lead are equivalent to 1.5 times 10 to the 12th atoms? So please set that up and get an answer, and we'll go over that in class. Great. The last thing we're going to do in this section is we are going to combine those things that we've been doing and learn how to do 2 different types of problems. So we've been converting between moles and number of atoms, and we've been converting between mass and moles. So now we're going to put them together and be able to learn, and we're going to learn how to be able to convert between number of atoms and mass. So, converting mass to number of atoms. As always, write down what you know, write down the formula, which is the original quantity times 1 mole over the molar mass in grams times 6.022 times 10 to the 23rd atoms over 1 mole. And that will give you your answer. And then as always, you substitute in your numbers, calculate, and check. So let's do this. How many atoms of iron are in an iron pipe that has a mass of 105 grams? So the first thing we're going to figure out is, what do we know? So we know we have 105 grams of iron. And we know that we're trying to figure out how many atoms. So the thing we're going for, our goal, is number of atoms. Next thing we're going to do is we're going to write down our equation. If you want to write down the formula, that's up to you, but you do need to set up the problem with me. So we're going to have our original quantity over 1, and our original quantity is 105 grams iron over 1 times 1 mole over our molar mass. And to find our molar mass, if you recall, we need to go to our periodic table. Find your handy-dandy periodic table and find iron, Fe. When we find the molar mass of iron, we know that it is 55.845, which rounds to the nearest hundredth of 85 grams. And then we need to take that by Avogadro's number. 6.022 times 10 to the 23rd atoms over 1 mole. And that's going to give me my answer. First thing I'm going to do is I'm going to cancel out the units that can. Grams on the top, grams on the bottom, moles on the top, moles on the bottom, and I'm left with atoms, which is what I want, so that's beautiful. Okay, now it's time for the math. I have 105 times 1 times 6.022 times 10 to the 23rd divided by 1 times 55.85 times 1. So basically 105 times 6.022 times 10 to the 23rd, and that whole quantity divided by 55.85. Do make sure you are using your parentheses correctly, or otherwise you're going to get a crazy answer. We will check our answers in our next video. Bye!